The Proxima Centauri star, our nearest neighbor to the Sun, has an extraterrestrial planet around it, and according to astronomers, something strange occurred on it. One of the most intriguing exoplanet discoveries to date, Proxima B, was made 6 years ago. It's a solid planet about the size of Proxima Centauri, the Sun's nearest neighbor, which orbits the Earth. Recently, the planet Proxima Centauri B became well known online due to speculations that it may contain extraterrestrial life. What is the most recent discovery that has brought the exoplanet under the spotlight? What effect does this have on our quest to find a new planet to call home? Let's find out. Proxima B is a planet that is only slightly bigger than Earth. Since it revolves in the star's habitable zone, liquid water and perhaps even life may be present there. Proxima B is still a strange alien world despite its similarities to Earth. The parent star of Proxima B, Proxima Centauri, is a peculiar stellar triple that astronomers are still trying to figure out. The other two stars are binary, which means they revolve around the same gravitational center. They together go by the name Alpha Centauri. According to astronomers, Proxima Centauri may be passing by the other pair of stars, or gravitationally tied to them in some kind of orbit. It would take 500,000 years for it to orbit Alpha Centauri if it were bound. If not, leaving the region would take millions of years. Red dwarf stars like Proxima were once thought to be incapable of supporting habitable planets due to their close orbital distances. Red dwarfs, however, may now be the ideal area to hunt for habitable extrasolar planets, according to astronomers. Case in point, Proxima B. The British publication The Guardian received information regarding a weird signal coming from Proxima Centauri, the star that is 4.2 light-years away from us. It was still too early to rule out interference from Earth, but the signal appeared to be coming from the direction of our nearby star. The improbable idea that it is a signal from a highly developed extraterrestrial intelligence was proposed. At this time, it is impossible to go to Proxima B, so astronomers have been observing the planet from a distance in the interim. In a preprint essay for ARXIV, Loeb, a Harvard astronomer with expertise in planetary atmospheric studies, worked with Creedberg. He hypothesizes that a civilization that tightly orbits its small red dwarf star and is thus likely to be tidally locked with a perpetual night side may deploy strong mirrors or use extremely brilliant LED-style lights to illuminate their cities. They assert that the near-infrared instrument on the James Webb Telescope will be able to detect artificial light if it is present by searching for telltale evidence of LED light waves in the light emanating from the planet and its host star. According to Loeb, they can evaluate whether or not this planet resembles a naked rock using the light they have found, says Loeb. Without specialized equipment, detecting the star Proxima Centauri can be challenging. But even with advanced sky-observing tools, it may be hard to see the exoplanet Proxima B. Astronomers instead looked at the exoplanet's host star to find it. The gravitational forces of a planet as it revolves around a star causes the star to tremble very faintly. The starlight experiences a Doppler effect, or change in the apparent wavelength as a result of these gravitational pulls. Using the European Southern Observatory telescopes in Chile, astronomers studied Proxima Centauri's alleged Doppler wobble and found that the star has a planet slightly larger than the Earth orbiting it at a distance of 4.3 million miles. The Sun, however, and this star system are very different from one another. A red dwarf star, Proxima Centauri, is a tiny star with around 15% radius of the Sun and is much cooler than the Sun. Thus, Proxima B is actually far closer to Proxima Centauri than Earth is to the Sun for it to be in that Goldilocks zone. A smaller star might seem like it would be a gentler star, but that isn't the case at all. Stellar flares occur far more frequently in red dwarf stars than in the Sun. Therefore, Proxima B experiences much more extreme space weather than the Earth because it is the nearest planet in another solar system with a probability of supporting life. People sometimes ponder whether mankind could potentially survive on another planet given the rising difficulties life on Earth faces as humans fight against enormous issues like climate change and its ever-worsening implications. Proxima B is not necessarily habitable, despite being in the habitable zone, which is the distance from its host star at which water could accumulate on a planet's surface. For instance, we have to consider whether the planet truly has water or whether an atmosphere could endure in that orbit. At this point, it's all theories. A suitable atmosphere is necessary for regulating climate, maintaining a water-friendly surface pressure, protecting against dangerous space weather, and housing the chemical constituents of life. Atmospheres are also crucial for life as we know it. In the computer model created by Garcia Sage and her co-workers, Proxima B's was represented by Earth's gravity, magnetic field, and atmosphere. Using data from NASA's Chandra X-ray Observatory, they also determined the average amount of radiation produced by Proxima Centauri. This information was used by their model to mimic the effects of the host star's frequent flares and powerful radiation on the exoplanet's atmosphere. The question was how much atmosphere is lost and how rapidly it happens. According to Ofer Cohen, a co-author of the paper and a space scientist from the University of Massachusetts, they could determine how long it takes the atmosphere to escape if they estimate the time totally, and then they could compare it to the planet's lifetime. When high-energy severe ultraviolet light ionizes atmospheric molecules, knocking off electrons and forming a swath of electrically charged particles, it sweeps the atmosphere away from an active red dwarf star like Proxima Centauri. The freshly generated electrons gain enough energy during this process to easily defy the planet's gravity and rocket through the atmosphere. Due to the attraction between opposite charges, as more negatively charged electrons escape the atmosphere, they produce a strong charge separation that propels positively charged ions into space along with them. Proxima B experiences severe UV radiation bursts that are hundreds of times stronger than those seen on Earth in the habitable zone of Proxima Centauri. That radiation produces enough energy to gradually peel away heavier elements like oxygen and nitrogen, in addition to the lightest molecule, hydrogen. The researchers looked at two additional aspects that worsen atmospheric loss to comprehend how the process can change. They started by taking into account the thermosphere, or neutral atmosphere temperature. They discovered that air escape rises when the thermosphere warms from increased solar radiation. The size of the polar cap, the area across which atmospheric escape occurs, was also taken into account by the researchers. At their magnetic poles, planets are most susceptible to magnetic effects. The polar cap is constrained and charged particles are kept trapped close to the globe when magnetic field lines at the poles are closed. On the other hand, when magnetic field lines are open, more escape occurs, offering a one-way path to space. This work examines atmospheric loss in the context of stellar physics, which is a neglected component of habitability, according to Sean Domagal-Goldman, a Goddard space scientist who was not involved in the research. It's crucial to make sure we account for these interactions in our models, because planets have many different interacting systems. The researchers demonstrate that Proxima B might lose enough of its atmosphere in just 100 million years, or a tiny fraction of its 4 billion years, if it had the maximum thermosphere temperatures and an entirely open magnetic field. That much mass escapes over 2 billion years under the scientists' lowest temperature and closed magnetic field assumptions. Since red dwarfs are the coolest, smallest, and most prevalent stars in the galaxy, they are frequently the target of exoplanet searches. Planets need to keep tight orbits because they are cooler and dimmer for liquid water to exist. However, scientists are discovering more frequently that this near closeness is not promising for an atmosphere's survival or sustainability unless the atmospheric loss is offset by some other process, such as a significant amount of volcanic activity or comet bombardment. We think if life exists on Proxima B, it would need to be a different kind of life than what exists on our own planet, since a species would need to emerge and grow under rather different circumstances. Proxima B's moons, if there are any, may have the best chances of maintaining life in the Proxima system, since they are not tidally tied to the star, according to researchers. It's likely to be frozen solid, so in the unlikely event that we might get there, experts suggest our best hope is to drill and look for life below the surface. It is advisable to look below because a red dwarf surface environment makes it very difficult for the planet to maintain life. What do you think of Proxima B's similarities to Earth? Comment below.